Section 3.3.5-T. The following data represent the high temperature distribution for a summer month in a city for some of the last 130 years. We want to treat the data as a population, and we're going to complete part A through C. So here's our temperature, and these are our classes. And then we have our days, which represents the frequencies. We want to approximate the mean and the standard deviation for the temperature. So what we're going to do is we're going to go ahead and open the data in StatCrunch. Okay, so our temperature is our first column, then we have our lower limit column, our upper limit column, and then we have our frequency, which is the days, which is the last column. We're going to look at the first and the last column when we figure out the population mean and population standard deviation. So we want to go to the drop-down menu for stats and then go to summary stats. Scroll to your right and go all the way to the bottom where you see grouped bin data. And then the bins in is going to be the classes, which represents the temperature. The counts in is going to be the frequency, which represents the days. And then we want to make sure that we select consecutive lower limits. So we're going to go ahead and do that. And then we're going to hit mean and control button for standard deviation. So now what we're going to do is go ahead and copy this into our program here. So if you take a look here, we have our population mean is rounded to 1 decimal place at 80.8, and that's what we can do here, is rounding it to 1 decimal place at 80.8. And then our population standard deviation rounded to 1 decimal place is 8.3. So let's pull up the data in StatCrunch. So we have our data. We're going to open up in StatCrunch. Okay, so I do want you to point out here, you have these 4 columns. We have our temperature, which is the classes. We have our lower limit, we have our upper limit, and then we have our days. Now this is the frequency, but this isn't the entire data. This is the summary of all the data. So here we have 332. This doesn't give you, if you add all these numbers up, it's not giving you the full list of what the frequency or of what the entire data would look like. It's giving you the summary. So in this scenario, we can't create a histogram from the histogram part. We need to look at a bar plot with summary to see what that's going to look like. Okay, so we're going to open that up. We're going to put categories that are in the temperature, and the counts are the frequency, which is the days, are in days. Okay, and then we're creating a frequency. We can put the values above the bar. All right, so now we're going to go ahead and select compute. Now when we select compute, we're going to take a look at this histogram. Okay, now the one thing I want to point out here is that it isn't necessarily going to show the exact graph, and I'll explain why here. Okay, and what I mean by that is that we have the right information in this graph. It's just that if you look at the bottom here, okay, this 101 to 109 should be on this side. So I'm just going to go ahead and copy this, and I want to show you what I mean by that, because this should go in the proper order. So this actually should be on this side of the graph. Okay, and so what I want you to notice is that they're asking us to determine whether this is bell-shaped or not. Well, by looking at this data, okay, we're going to first just get rid of this part here. So we're not going to pay attention to that one now because we moved that to the other side. Okay, and so when we look at this graph, okay, that we generated through StatCrunch, if you look at this, it's forming a bell-shaped distribution, and it matches what we have over here. So when we're creating a frequency histogram from a distribution, meaning that we already have the summary, then we're going to have to go and use the bar plot option in StatCrunch to be able to do. And for part C, it says, according to the empirical rule, 95% of days in the month will be between what two temperatures? Well, let's go back to the definition of the empirical rule according to 95%. Well, since 95% lie between the mean minus 2 times the standard deviation and the mean plus 2 times the standard deviation, we want to find the lower and the upper. But what we need to go back is take a look at what we found for the mean. So recall that the mean is 80.3 and the standard deviation is 8.3. And so we're going to use that information to find the upper and the lower parts. So the low is taking the mean, 80.8, and subtracting 2 times the standard deviation, which gives us 64.2. And the high is going to give us 80.8 plus 2 times 8.3, which is 97.4. And therefore, according to the empirical rule, the high temperature for 95% of days in the month will be between 64.2 degrees Fahrenheit and 97.